Everybody knows digital integration and saving energy in any system is need of the time. So coming to, it's a general question, starting with Mr. Goel. For saving energy, what various parameters like thermostat or design aspects need to be considered for enhancing HVAC systems as well as component efficiency?
I will first go into the system efficiency part of it. If I'm a very practical person. In a year, we go around to 20 energy conferences or more. And everywhere we find just one single common thing, that you are freezing. We are doing an energy conference over there, and the temperature is 20 degrees centigrade. And people are pulling out jackets and, they say, stop the system, it's too cold. What are we achieving with that? So you need to take charge of overcooling. And taking charge of overcooling, overcooling indicates that you have lost control over the system. B, you can easily mount a small sensor like this. This is the size of the sensor. Doesn't have any wires, nothing. You mount it at 10 different places. You pull out your handheld phone, and you will be able to see exactly how the temperature is tracking at every particular point. And you will be aghast to see the kind of temperatures that we maintain in hotel lobbies, conference rooms, empty offices, and things like that. And that itself will bring down system level power saving to a great extent. These are very, very simple things. Now let us look at the component level power things. You have air handling units. If you don't do energy monitoring in an air handling unit, is it reacting to the temperature outside? Say, for instance, it's a simple office. You have VAVs installed, and it is taking constant energy right through the day. What is it telling you? It's telling you that the variable frequency drive is not working. I don't know if most of the panelists will agree with me or not, but over 90% of the variable frequency drives installed on air handling units in India do not work. The only 10% that work are in the pharmaceuticals or at places where really things need to get controlled, very controlled environment. Either they are put on direct or they are put on bypass or whichever way. And with such costly equipment, what are we doing? We are just losing energy. We are losing the money that we use to install it. And the figure is over 90%, which is really astonishing. So measuring energy in a less than 100 kilowatt motor today does not cost you more than 17 to 18,000 rupees, the kind of items which are available on the internet today. Okay. And it takes a normal electrician to install it, and you see all your data on handheld telephones. I'm to say it's as simple as opening an app on this thing, go to the power monitor, and it gives you all your power and energy data. And if you want to look at your consumption, then here is your consumption. You go to your weekly consumption, past 7 days, and it is telling you your weekly consumption. So basically what is happening is that your visibility is growing n-folds. It doesn't need a rocket scientist to do all these particular things. Unfortunately, in India, even power companies, we have found very, very senior companies installing one energy meter at the entrance of the building. I have talked to the senior most electrical consultants, and we are really trying, Mr. Gautam will tell you, we are really trying that every air handling unit, you should be able to put an energy meter on. And if you don't need it, take it out and use it for something else. But at least during commissioning, put it on for 10, 15, 30 days and see if you are getting the variation or not, the daily variation and the season to season variation. So these simple things can lead us to net zero and decarbonization. Let us not talk about big things till we do these small things.
Thank you very much, Mr. Goel, for giving us the practical examples. And so, Mr. Sandeep, for saving energy, what various parameters like thermostats or the design aspects need to be considered for enhancing HVAC system efficiency?
Many small equipments can be used, like a temperature sensor for monitoring the various location where we can find a pattern and you can design your system based on that. Even the VFD commissioning, if you are using VFD on a HU side, that can be commissioned by using maybe a different energy saving strategy, can be a differential, the pressure based, can be a temperature based. It will able to save lot of energy. When I see a overall HVAC system, then you have mainly you can control on the HU side where you can control the air side energy consumption, and on the chiller side you can control the water side or the chiller side consumption, and you can have a different strategy designed for this particular thing. Unfortunately, while designing HVAC system is always designed for a worst case scenario, and the consultant like Gautam sir and many other prominent consultants design systems at optimum level. They provide different components which can be used for energy saving potential. Basically, what happens is sometimes somewhere down the line, the implementation strategy is not passed to a facility team properly. The people really don't have a necessary skill set. So people, uh, a consultant who has designed a particular system, a BMS companies have implemented that strategy during the commissioning stage. During course of action, the strategy implementation strategy lost, uh, components failed, then the people don't have enough budget to replace that particular thing. Many times facility team don't know how the VMD logic will work. And so the component efficiency or components started failing or performing erratically, and that will then that the error will pass on to the system efficiency also.
Thank you for sharing your views, Mr. Sandeep. Mr. Gautam, as a consultant, you have to guide us about the various parameters.
With respect to any system design that we do, we have to take into account the worst case scenario. And the automation or control system comes into picture when the system is not functioning at the design condition. That is where the actual the energy efficiency aspect, energy efficiency aspect of the system functioning comes into picture. So, for example, like when we do a system design for a room, we assume that, for example, like we have started with a banquet hall. So let us start with a banquet hall. The banquet hall is designed for a particular condition, for a particular number of population, for a particular amount of heat that is uh, coming from the equipment or the exposure and the external conditions. These are different parameters based on which a banquet air conditioning system has been designed for. But in practical scenario, all may not be happening at one go. It may be one odd case scenario which may happen, but the system should be able to function for that one odd case scenario. In which case, the system can function for any other case scenario subjected to the control system is functioning properly. So this is where the problem is. Like the system has been designed for a particular population, particular exposure, particular outdoor conditions. And actually, when the system is functioning at that particular point of time, when we're talking about the space is being freezing, the assumed maximum conditions were not prevailing. At that point of time, the system has to take into account the control logics that the VFD has to ramp down to a particular level so that the temperature of the space is not going defined set point. And if the VFD has already ramped down to a particular value, then the chill water control should happen so that the maintaining the same delta T and reducing the flow rate, maintaining the space system conditions. So like Prabha sir has already pointed out that people and Mr. Sandeep was also indicated that if some component has failed, the importance of that particular component has to be known by the user first, without which the actual system design intent is not met.
Mhm.
So for example, if VFD has gone wrong, they put it on a bypass mode and keep operating. The VFD may not be costing 20,000-30,000 maximum, which may not be equivalent to 10 plates of banqueting cost. But still, people are not interested in uh, interested in investing that capex rather than they are more into they are least bothered about the investment of that capex, and they are not bothered about the opex that they are losing in this process. So when a system has been designed, the system design intent has to be understood by the user. And if it is functioning as per the design intent, then the efficiency can be achieved. So this is my summation that the user has to understand how the system is designed and what is the condition of the system. And then he has to use it as per the designed conditions.
Thank you, Mr. Gautam, for sharing the valuable points.
Thank you.
Mr. Suresh, he was talking about the design aspects and he was talking about PLC logic also. So you were also mentioning the PLC logic in the big buildings and the AL and ML control. So what innovative IoT devices or wireless controllers are available for real-time monitoring?
So in HVAC industry, there are a lot of wireless devices are available. So we see in normal operations, temperatures and CO2, your RH and occupancy. So these wireless devices are available for the in-house operation. So on your DDC controllers and other things are available for your building control, basically. So this can be nowadays it comes with either it can be connected to a LAN or it can be connected over a Wi-Fi or can directly communicate or a SIM. So a lot of options are available nowadays.
Thank you, Mr. Suresh. Mr. Harsha, data analysis, as you were talking about, that is needed. It is very important for the quality and reliability. So what role does tools and cloud computing play for digitalization in HVAC with regard to data analytics?
So I'll just give you a small example, wherein I was saying, since I have been associated with, constructing data centers over, quite a few time now. So, data centers, of course, is all about data. But, to understand whether the data is rightly protected or no, there is a lot of engineering that goes at the background of it. And that needs to be ensured whether all the particular things are in place or no. Since we are here particularly concentrating on HVAC, so I will just say that, a lot of customers come in with their very strict SLAs.
Mhm.
Okay, so the customer, let's say, if he has installed, maybe a 3 megawatt of data hall, wherein he has, let's say, about 300 or 400 servers. Okay, so he'll be saying that my, the air inlet at my server should not exceed beyond, let's say, 28 degrees Celsius. But how do we will ensure that this particular SLA is not breached. Okay, so if at any point of time, let's say, if data is, there is a certain breaches of SLA is happening, there is a certain penalty that comes across along with it. Okay, so basically, all this, understanding of the data, that is, let's say, for example, whether wherever this customer's, hall is situated, a continuous monitoring of all the, the air handling units and the continuous monitoring of the, the water side parameters are there in the BMS system as well. But what happens is, this entire data, the customer, let's say, will be at a global platform operating at a very different, time zone, different location. But he will be monitoring your complete entire system through a common platform. Okay, so all your data, maybe, though it is connected to a common DCIM, maybe a data center infrastructure manager that we call it as, the person XYZ person in a different continent, different time zone, still he'll be able to monitoring at what exactly the flow is there in your hand handling units. What is the exact flow that is there across your pump? What is the flow that is exactly happening at the chillers as well? So what they do is there is a regular monitoring that is happening not only at the field level but also at the global level as well. So just to ensure that the continuity is maintained and the SLAs are not breached.
Thank you, Mr. Harshad, for pointing out these valid points. Mr. Goel, with digitalization, how much power saving can be achieved in HVAC system?
Not good to just put a number. It's not like throwing a dart at a dartboard.
Right.
But going forward, you will at least save 20 to 30% on the total grid power by going digitalized. See, for instance, if you look at the unoccupied offices, which still run air conditioners, both in public sector, private sector, government, everywhere. Now you have what is called geo mapping. When you open your handheld, it says, give me your location, right?
Right.
You can get your systems to start and stop based on geo mapping. That means as soon as you walk out of your office, your little room AC or split AC will go into fan mode or it'll get out of the compressor. Can you imagine the amount of power saving on the grid that you will get with this one single function? That unoccupied places people are not running the air conditioning. Number two, we are in winter right now. A lot of us use water heaters, right?
Right.
And you put the switch on, sometimes you forget, and you say, okay, the water heater has got a thermostat, it will heat the water, and then it will stay till tomorrow morning when I have a bath. Can you imagine how many times, how much heat it loses to the environment? To whose benefit? No one's benefit. Now, what you get is smart plugs. Unfortunately, even the biggest of power companies have not come out with their own cloud with a smart plug. We are using Chinese clouds and other clouds and things like that. Now, you just put a timer on it. You have a bath, you want it between 7:30 and 11:30. We put a timer on it and say, okay, please switch on between 7:30 and 11:30. And what it does is it switches on at 7:30. See, this is asking for the geotag, okay? And after the geotag, you go to your thing, and this is your on-off button. If you press it over here, it will override the timer and it will come on. And it will give you exactly how many kilowatt hours you have taken on your water heater on a daily basis. And then you can go to every month. You can go to every month and you can see how much power you have consumed on a day-to-day basis. And once you start digitizing, people start looking at it, you start controlling and say, all our energy bills don't come free. People complain that my energy bill is too much. Okay. And what happens? We don't know what we used. Where did our energy go? So once you digitize and pass on the information to people, you are bound to see reduction in power consumption. And that is how we should go. All intelligent people from class 9 onwards should be taught what is energy, how is energy produced, what coal burning causes, which gives us the energy, and how we should look after energy use and how we can conserve it. That means every person is, to some extent, an energy manager. If you want to go to net zero and good terms like that, decarbonization and all, people will really have to work.
Definitely, Mr. Goel. Education is needed and awareness is needed for that purpose. Mr. Suresh, so much data is being created and so much load are there, so many data analytic reports are there. So are any cybersecurity measures being implemented for digitalization for protection of the sensitive data?
Yes, definitely. So nowadays, all the equipments, even the building automation equipments, the softwares, so everything is coming with 128-bit, what do you call that, protection. So 99% of the time, you will not be able to crack that 128-bit encryption. So it is a basic requirement of the IT industry. Nowadays, all the BMS system, everything is data is and flowing through the building IT network. So this data safety is very important nowadays. So this is a must thing.
How do you train the people to read the data that comes into being because of the digitalization?
Okay. So the management level, we can generate a lot of reports. So that can be viewable or readable by a layman also. So it is not just simply data we collect, and if you give to any one of the user, they will not be able to understand it. Simple data. So it has to be formatted in a way that is the layman should understand it. So that is how we should present the data. So that is possible with any of the building management system or IoT system. So this is possible.
Yeah, okay. Thank you very much for sharing the views. And lastly, coming to Mr. Gautam, what are the smart adaptive ways that AL algorithms can enhance the efficiency of HVAC system through predictive maintenance?
So basically, the power consumption, for example, if you are looking at a particular air handling unit and it is supposed to run at a particular RPM at a particular speed, and if there is an undulance in that, it is observed that for the past few days it is running at a different RPM than what it is designed for. That will give an indication that there is something wrong with the system or about to go wrong with the system. So this kind of inputs. So basically, the main thing in any energy efficiency, HVAC energy efficiency is basically anything which can be metered can be controlled or monitored can be controlled. The metering and monitoring is a basic aspect for any control or energy efficiency be to bring energy efficiency in place. So if we have some metering, we know that on this day, on this condition, during these conditions, we have consumed so much power. So we can take necessary action to reduce that or improve the efficiency accordingly. So coming to your question, like, so we can get to know about the deviation that is happening from the standard operation procedure. Say, for example, like I've indicated that the fan is running at a 2900 RPM, which it should be running, and it has suddenly gone higher or lower for any reason. That indicates that something has happened because of which the fan is going or behaving absurd way than what it was supposed to function. So this can result in proper cross-checking of the physical equipment, and we can identify there could be some problem, there may not be some problem, but this kind of undue uh, uh, deviation from the standard operating procedure will give an indication, and predictive maintenance, prior maintenance can be done before the system totally fails.
Thank you, Mr. Gautam, for sharing those points. So, Mr. Harshad, what are the challenges that can be addressed for implementing IoT technologies?
Challenges basically it's just infrastructure first of all. There needs to be a infrastructure has to come to a certain platform so that this can be taken ahead. Next is the of course like you spoke about the upskilling. So upskilling of course is going to be one of the challenge and that needs to be lived upon. The good part is that we as humans are very good adapters. Okay, likely you can just see today people going across any local shop, you can see how people have very well gone ahead with usage of UPI and everything. No one went ahead and taught to them how it has to be accepted, but it's just about the awareness that came in with, and people found it handy and they found it that it is of very much use to them. Okay, so similarly, it is about making people aware and how the benefits and everything can be brought on the table. It is just not on the aspect of energy. Yes, of course, that is going to be the more primary and the deciding factor. But a lot of things that it brings on the table, like ease of the operations, having minimum downtime. We spoke about preventive and predictive maintenance and everything. So a lot of other parameters as well. It will help you to to mitigate them. So the challenges, of course, is going to be the infrastructure and making people aware. I think that's and the upscaling. These are the three parameters I think which needs to be looked upon, and I think we are on the track to that. And I think in going forward, we can see a lot of systems and everything coming and moving towards the IoT systems.
Thank you very much, Mr. Panchal.